was lying there in her bed, gazing into her dad's eyes and waiting for a response, waiting to be reassured. Her dad, who was strong all this while, broke down into tears. There is no cure for paralysis. It's 2034. We have exhausted our natural sources of drinking water. We now are reliant on the sea water for all our drinking needs. Millions of people across the world who cannot afford this expensive desalination process are suffering and consequently dying every day. It's 1965. Gordon Moore came up with the Moore's law, which basically says that the number of transistors on an IC chip will double every 2 years. We have since then obeyed Moore's law. However, scientists cite that due to technical limitations, we will reach its deadline in 2024. Now let me tell you a story about two scientists from the Manchester University in United Kingdom and their little experiment. So what they did is they took a piece of graphite, the thing at the end of your pencil, they crushed it into pieces, they placed it on a scotch tape. They took another piece of tape, joined the two tapes together and then separated it. Now when they did this, what happened is the pieces of graphite, the number of layers reduced on each surface of the tape. They repeated this process several times, 15 to 20 times, until they came up with something very interesting. What remained on the piece of scotch tape was just one layer of carbon. They won the Nobel Prize in Physics in 2011 for this discovery. Graphene. Remember the word graphene. It's so new that the spell check on your phone doesn't know it exists yet. However, this is going to be the breakthrough product of the first half of the 21st century. Now, some properties of graphene. It's the first 2D crystal ever known to man. It also happens to be the thinnest and probably thereby the lightest material we've ever laid our hands on. It is also the strongest material, stronger than diamond and 300 times stronger than steel. Graphene, or as industry experts like to call it G, conducts electricity really well. In fact, 100 times better than copper. What's more, it conducts electricity best at room temperature. Graphene is transparent, it absorbs very little light, it is bendable and extremely flexible. Electrons behave in a very funny way in graphene. That is to say, certain laws of quantum physics do not necessarily apply when electrons travel at that speed in graphene. Now, you guys remember little Cassandra from earlier? We might have a solution to her problem. Medical experts are really optimistic about the facts of building bionic devices that could help facilitate communication between neurons in the lower spinal cord and neurons in the upper spinal cord, thereby curing ailments and diseases that till today we've thought as incurable. Another important property of graphene is it allows, if you have a large sheet of graphene, it allows only one material to pass through it. And surprisingly, that material is water. So you can imagine where I'm going here with this. And scientists have also estimated that the cost of production of clean water using this way of graphene sheets is going to be 1% of the cost that it actually costs today with any known method. And as technology improves, the cost is just going to drive down further. You all probably have seen those flexible touchscreens that Samsung has out. If you're thinking graphene, you're thinking right. So these guys, Samsung, have about 407 patents already in the graphene industry. They are by far the leaders in research in the graphene industry. Other cool usages of graphene that scientists are exploring are supercharged batteries. And they peg that this is going to just change the way we live. For instance, think of charging your phone. You connect your phone, within 4 to 5 seconds, your phone is fully charged. How cool is that? It is also going to be vital to the sustenance of electric powered cars, because can any of you imagine yourselves waiting for an hour for your battery to be charged? So graphene is just going to change the way you and I live today. And let's not forget good old Gordon Moore. Just by the substitution of silica with graphene, the chips are going to run 10 times faster, pushing that 2024 deadline slightly ahead. So that's all what I wanted to convey today about graphene, and it's very exciting times for graphene because the European Union has committed to investing 1 billion euros in graphene and graphene related research. China, on the other hand, is also a forefront player in the graphene research industry. They have 2,200 plus publications and white papers already in the field, and it's just increasing. Other big players are Singapore, where they've set up this big research lab, and the scientists have tapped into graphene's superior imaging capabilities, and they've already made a sensor that is 1,000 times more sensitive to light than any known sensor today. So this super thin, super transparent, super strong material is going to revolutionize the lives of everyone around us in the coming few years. And in a few years, it will be funny, but to realize that it all started with a piece of graphite and a scotch tape. Thank you.